Welcome everybody to the YCARS Clubhouse. I'm John Jenner, I'm trustee for the club. My call sign's NJ4Z, and this is our presentation meeting for April 2021. We're live on YouTube right now, so we're glad to have you all in the clubhouse. It's good to have some folks here tonight. I see some new faces, so wonderful to have you. And I want to introduce to you our presenter tonight, who, if you've been in a club for any period of time, doesn't really need any introduction, but since he's a living legend. But this is WB4QNI, Steve Kelly, and he is a master of all things ham. So I'm going to turn it over to him. Thank you for doing this tonight, Steve.
Thank you very much. Thank y'all. I really appreciate it. I'm glad to be here tonight. It's good to see all of you. And if I get to boring you with some of these things that you already know, then I might be passing on to you. Just try not to look too bored. But then if you're really getting really bored, just do this number here and I'll know to wind it on up a little faster. So that way we can kind of control the atmosphere within the group here. But I'm start off, I want to talk to you about different little things I've found over the years that have helped me do a better job, an easier job of being a ham radio operator. This is not about designing and building big antennas or anything. We can do that another night. What this is about is just little tricks of the trade, better ways to do things. Some of them you probably already know, some of them maybe you figure they're not even worth knowing about, but they've helped me over the years. First thing I want to talk to you about is tape, black tape, electrical tape. Buy the best tape you can buy. Don't buy the cheap stuff in the cheap places. Go where the electricians buy their tape, and don't worry about the price. Because if it's out there on your coax and it's working for a $1,000 radio, the tape price doesn't matter. Buy good quality electrical tape. Now, there's a few tricks about tape. First thing I want to tell you about is when you're wrapping up anything with black tape, it's a stretchy type tape. So you want to wrap it tight. But when you get down to the last place you're wrapping on the thing, you want to stop and leave about 4 or 5 inches that are not stretched. The rest of it you put on, you stretch it, but don't stretch the last 3 or 4 inches. Cut it at a 45 or a sharper angle. The reason for that is when you wrap that last little bit on, just press it on. Don't stick it on hard. Don't stretch it. Just stick it on, and then there's no tension in the end of that tape, so it's not going to want to roll back up on you and come off. Because you've seen tape that wheels back up, but that angle will help stop it, because all the tension is not just right across the face of the cut. It's in that cut that's at an angle. So it's kind of, the tension is going a little bit different there, so it won't unroll with you as quick. So do that to your tape when you're putting it on. I'll tell you some more about tape, other things about the electrical tape in just a little bit. But the cutting, the wrapping, and the stretching, you don't stretch that last little bit. Now, we can use tape for shims. Like duct tape makes real good shims. You're going to put up a pole and you got a piece of pipe in the ground, you're going to stick it in there, and it's a lot of slack in it, so wrap you some duct tape around it and get it up to where it's going to be kind of tight in there. I got one I'm putting up in a 3-inch pipe, and it's a fiberglass pole from MFJ, and I'm going to stick it down in that hole. I'm going to put a little bit of sand in there around the bottom of that pole to keep it from wobbling around, but then I can always pull it out of the sand if I want to take it back out. But up at the top, I can wrap tape around it just a little bit, hold the pipe up a little bit, pole up a little bit, get down a little bit below the top of your piece of pipe that you're going to stick it in, and wrap your tape around the pole, and then fit it in there, and then that little extra edge that's sticking up, then you're going to start working with some putty. Now this is a real good kind of putty that's very reasonable to use for any time you're putting up anything on one of your situations there, antenna. This comes from Home Depot, and you find it in the weather stripping department. Go to the weather stripping area where they're selling things for weather stripping, that sort of thing. It's a lot cheaper than what you'll pay for coax seal. And it works just as good, and it doesn't get hard. And I keep mine in a plastic container there zipped up. But it's a real good product to use as far as that type of thing there. Now, another thing on tape is you need to keep some colored tape around. I find colored tape is really, really good for when you run your coax into the building is to tape up the different antenna wires, different colors. That way you know what they are. Like my best antenna right now, HF antenna, is red. And the secondary antenna I'm putting up is going to be blue. And my 2 meter is yellow. So when I look over there at the window, there's my wires coming in and they're all in a conglomeration, but at least I can see what colors are on them. Now, like if one antenna could be put on my little 2 meter radio, I mean not 2 meter radio, I'm sorry, my little HF, QRP radio, well, I got it yellow, so the wire, the radio is yellow, the wire over there is yellow, so I put yellow on an antenna that will go to it as well as my other radio, which is red. So there's yellow and red on the same wire, but they mean 2 different things to me. So color tape can be real handy about marking your coax and stuff there. Now, cloth tape measure. I'll talk to you about that. This is a piece of cloth tape measure. You go over to the sewing section at Walmart, you go in, you find these things, they're not very expensive, and you buy you one, and you take it home and you cut the thing off to a reasonable fair length where you can pull it down here, and you make your little loop of rope in it, put it together there, and now, oh, we can see that that is 23 and 7/8 on there. So we write that in our book. Next time we move this thing, we'll just check, whoa, it's in the wrong place. So we just pull it back up there where it's supposed to be. So this little thing's lightweight. If you're portable, it's the lightest thing you can get to measure. I've seen people use a stick with markers on it, a piece of plastic. I saw one company that sold a big old thing here that had all kind of numbers and stuff on it. This little rascal right here will do the entire job for you. You won't have to worry about it. And it's lightweight, and if you keep the piece you bought, you lose this one, you just cut you off another piece, because it doesn't matter what number's on it. It just matters what number's where you want to be. So it works out real well there. That particular type of tape. Let's see. Okay, now, long tape measure. Everybody that messes with antennas needs a long tape measure. Now this is an old, ugly steel tape measure, but it's still accurate because it's steel. I have used cloth tape measure, but I like the steel ones better. Now, 2 things about this. If you measure an antenna wire, you need to set up in your shop area, or wherever you're working, a way to hook this tape measure in some manner, and also hook the wire you want to measure. It needs to be anchored. There's different ways to do it. In my case, I had one set up at one time where I had to always add a foot, because I had that tape mounted a foot behind where I put my wire. All right, you pull it out there, then you're going to see a long piece of wire and a long piece of tape, and you got to adjust it so that they're the same height off the ground, so they're the same length. Now, when you get to that insulator, we'll just say that you know which one you're going to use. Maybe you don't at the moment, but you know how long you want that wire to be. Well, you measure to the hole in the insulator. That's where you measure to. All right, you run your wire out there, you get your mark, then you can stick your wire right through the hole and bend it 90 degrees, stick it through the hole, and then you say, well, Steve, that thing's in the right place. I'm just going to go ahead and put the insulator on it. Well, if you do, you need your wires coming in and going through the hole. You bring the other piece up. We'll kind of push them both together right out here so that when you twist them together, you're not tensioning on your insulator at an angle. You're pulling straight off on your what they call a crossbone insulator. So then you twist a little bit around. But leave about 4 or 5 feet on that piece of wire, so if you need to stretch it back out some, you can. If you wind a little bit of the wire around the other wire to get it substantially stable, then just wrap the other loosely around the rest of it. The signal stops at the hole in the insulator. It doesn't stop a little bit before it or a little bit after it. It stops where the hole is when it's coming down that line. So that's what you want to measure to. We'll talk about measuring in a little bit. Now, these 2 little jewels right here, I call them pipe cleaners. My wife tells me that they have another name in the craft store, but they're the best little things in the world for bundling up stuff. They got a little wire in them, and you can twist them together and make long ones if you want to. The trick to these things is when you put them together, always twist them together from left to right. You say, well, Steve, that doesn't matter. Well, when you go to take it off, which way you're supposed to turn it? I don't remember how I put it on there, though. Left to right. Well, if you always do it the same way, left to right, you'll know how to twist it off, because if you start messing with it, all that fuzz on there covers the wire up, and you can't tell which way it is, so then you get your cutters, cut the thing off, and now it's not as valuable as it was. So these are really good little things to keep on hand. All right, let's see what we got next here. We got cover the footing, cover that. All right, let's change the page. Now, we're down now to Scotch tape. You're going to say, Steve, what in the world are you using Scotch tape for on the radio? Well, it gets real handy. You got a little device like this little thing right here. Let's see, this thing is it's a code oscillator. Well, it may give me a little trouble, or I might decide I don't like the speaker in the back of it, and I want to run me a jack in here and run out to a bigger speaker or something. But in this case, it's already got a hole here, so I don't have to do that. But I want to get that screw out of it. See a little tiny screw that's in the back of that thing right there? I get my Phillips screwdriver out and I loosen that screw up. Now, normally you loosen it up, shake it out, and you can't find the full thing. If you do, you can't pick it up with your big old hands, old fingers, and not like me. So what you do, when you get it loose, you get your little piece of Scotch tape and you stick it on the head of the screw. And then you lift it out and lay it aside and you work on it, do what you want. When you put it back, put it in there holding the tape, the little cheap plastic tape. You put the screwdriver down there and punch a hole in the tape, tighten the screw up, pull the tape off, throw it away. You hadn't had to get under the table to find that screw. I have had to do that, so I know this works. That's another little trick I want to pass on to you. Let's see. Now, volt ohm meters. Really good things to have. Need to make a little change on them though. They ship them to you with two really, really nice leads on them. You got a red one and a black one. And that's really handy. I do a lot of continuity testing, so I can, anything that's setting still, well, I can just reach over and touch two things and get a reading. But what if I got to hold the full thing and then get, how am I going to do two of these things? So what I did, got the thing out, and I cut the black wire off of it. I just cut it right here, right under that red stuff. Cut it off. All right, I skinned the wires back so I could piece it together. I got me a piece of white wire. I wanted something different color than the other two. I didn't have any green handy, so I used the black though and white on it. And on the white one, I skinned it out and I twisted all three of those pieces of wire together. Now, before I started, I put me a piece of shrink tubing. I don't know if y'all are familiar with that stuff, but it's great. Really good. You can even make handcuffs out of that stuff if the guy can stand the heat. But anyway, you put it together, slide your tubing over it, and heat it up. So now, we got another piece of wire that we're going to have an alligator clip on the end of it. That's a little ugly alligator clip. All right, now, you're working on something. You can clamp that rascal on to whatever you're working on, and you only got to hold the red lead. And your black one can just go wherever it wants to. So now, it's a lot easier. You don't need that third hand to hold whatever you're working on. So you've got this on there where you can do it. And it didn't hurt a thing. I mean, the meter's happy. Nobody's been hurt by it. It's just a matter we added a little something to it to make it a little bit better. That's another little thing that I've tried to do over the years to improve and make it easier to work on stuff. Let's see. All right, ground systems. I understand y'all had a program on grounding equipment. Is that right? Okay. All right, well, I'm going to tell you a little bit about grounding, and I may cover something that's already been covered. I did not see that presentation, so I apologize for that. But the first thing I do, I buy ground rods. Usually they're 8 feet long. I cut them in half, what it normally do to them. Sometimes you have to grind a little more corn on one piece you cut off of it. But anyway, I want to drive that thing in the ground. Well, sometimes you get into really, really hard soil. It's aggravating to try to drive that ground rod into the ground. And if it gets too bad, then your rod's going to start flopping around with you just a little bit and won't depend on you. So anyway, if you get you a washer, a little small steel washer, it's got a little hole in the middle, which all washers do, and you want it to be about the size, but a hair bigger than your ground rod. That's what size you're looking for. And you put that down on the ground where you're going to drive that ground rod, put the point in it, and when you drive it, it's going to push that dirt down and away as you drive that rod in the ground. And when your rod gets down about 3 or 4 feet, it starts dragging on all that dirt you've driven it through. But if you do that, it'll make the hole just a hair bigger as you drive it down. You say, well, Steve, it's not going to make very good contact. Well, damp dirt's going to come right back around that thing, because I don't believe it, try to pull one out after about 4 or 5 days. You see what I'm talking about? But that right there will make it a lot easier to drive a ground rod into the ground. Now, next thing, they sell these kind of clamps. They're called water pipe clamps. They're made with a clamp that's put around the water pipe, and then you put your wire over here under this screw and tighten it up. So now you have 2 contacts, one on the water pipe and one under the screw. And this has gotten kind of rusty and dirty, so I don't use it anymore. Anyway, get you an Acorn attachment for a ground rod. This is an Acorn attachment. I don't know if y'all can see that out. It's just a big old loop of metal, and on this side it's built up with a screw in it where you tighten it up. Okay, get your ground wire. I like to use number 8. Get your ground wire and run down about, say 8 inches, 9 inches or so, depending on how much rod you're going to leave sticking out of the ground. I usually leave about 2 or 3 inches. But scrape off, just a second. Scrape off the insulation. Get this unit here, have your stake in the ground, and then you put this on here, slide it down to your ground rod, right where your metal is exposed, your wire's exposed, and tighten it up. Before you do that, if you lay this over on a piece of something solid, like somebody else's walkway or something, and beat it flat just a little bit, that way when you put this on there and tighten it up, it'll bend it around that rod a little bit. Now, you say, well, Steve, now you're sitting there with a rod in the ground, a piece of wire sticking up, and that stuff's going to hurt me. Well, just bend it over and stand in the ground, and no longer got a hazard sticking up anywhere around your ground rod to bother you. If you don't, sooner or later you're going to be messing with it, and it's going to cut a hole in your hand. So that's the way to keep from doing that. So wire your ground wires up that way with these kind of fittings. Much better way to do it. Now, some people use lightning arresters. I've used them, never knew if they were working or not. Never sure. So I did a little research, and I found another way to do a ground. And when you think about all that lightning coming down that, if you get a real bad strike, it's not going to matter what you got there. It's going to go every which way. But if you run your, say it's a piece of coax run out to your antenna, a little vertical antenna, get your piece of good copper wire, wrap it around your coax, and coil it around it, space it out a little bit as you go, and ground that piece of wire. That's what we're talking about. Now, when all that electrical energy comes down, it won't care if it's on the inside, the jacket of that coax, or what it's doing. It's going to get on that little piece of wire and run to the ground, too. So that's another way to do a ground. Now you're traveling. You're out here going to a motel somewhere, or going over to your buddy's house to spend the night. Well, maybe you don't need to do that. But anyway, if you're out and about, you're going to have a ground. A good way to do it is go down to the hardware store. I like to go to electrical stores, where they have supplies of electrical stuff, which is in a lot of places like those. A real good plug, male plug. I guess I ought to say male. I told you I'm not supposed to say male, female. But anyway, right here, a male plug. I guess you could call it something else. But anyway, a male plug. Buy that. Get a quality one, and take you one piece of wire that's good and flexible, you can use as a ground wire, good and tough wire, and hook it onto the ground plug, leg that's in that plug. The 210 volt legs, leave them alone. Just tighten screws up on them so they don't get shaken off somewhere and lost, and you can use the plug later on for something else if you need to. But put it on that ground connector. Put in the most electrical systems that have 3 wires, then you will have a ground. And that way you can use it if you need a ground for your equipment or something like that. You got a ground inside the building off of their electrical system. They got a neutral, they've got a hot side, and then they've got a ground side. And that's a good trick you can use for that right there. Let's see, what we need to tell you about next. We can cover all that. Now, get your cables into the house or into your shack. You can drill a hole in the floor, drill a hole in the wall, you drill a hole in the ceiling, whatever you got to do. Usually if you're going to drill a hole do something, put it under a cabinet or behind a cabinet or something like that if you can to hide. But anyway, there's no trick you can use if it's a crawl space house and it has registers. There's two kinds of registers. There's one, I think you call them 4/6s, but anyway, it fits on the floor flat, but it's against the wall and the baseboard stops on each side of it. That's the registers I've dealt with. There's a flat top register also that sets over the boot and the air conditioning heating system. All right, if you'll take the cover off the one that sets against the wall and look in it, the boot's about that wide and the register's about that long. So there's a little flat piece of metal on each end. You can drill you a hole through that. Take this cover off now. Just leave the base there. It'll be screwed down. Drill your hole through the metal, through the floor, into the crawl space, run your wire through it. Now put the cover over there on the shelf in the closet. Then when you move, pull your wire out, put the cover back on it. Nobody knows there's a hole down in the bottom of that register that's not bothering you. Another trick you can do is go under the house, find that boot that's going up through the floor. Usually you can punch a hole in a lot of the ductwork that's on these systems. It'll be the type, they call it flex duct. It's got a wire spring-like stuff in it. And you punch a hole in it, stick your wire over in the duct, go upstairs, take the register out of the hole and stick your wire out, then bend a few of the little fins on the register, run your wire through, pull it through, put the cover back on it, and then when you move, just pull the wire out and don't worry about the bent register, it doesn't matter. It's a good way to get that up in there too. Now, another thing you can do is use what I call a window strip. Piece of metal that expands out, locks, and put in. Charge you money for that thing too. But anyway, it's got these things like this made through it, which are barrel connectors, coax. They got bolts through them. They got other kinds of plugs, PL for the power pole plugs, different things. What I do, I just get me a little piece of wood about that wide, about that thick. If you look at your window, there's a little lip that's holding the sash in the window. Now my sash on my house now have little catches. So I can't push the window up but just so far unless I move those catches out of the way. So people can't break in if you got that unless they can get in and then raise the window up. So anyway, cut that board to fit so it's tight in there. Then cut that board in a couple of places near the middle. All right, now you can drill holes through one of the pieces to run your coax through. Two pieces. But you can't put it in the hole with those two little lips holding it, is holding the sash in. So if you can slide it together a little bit when you take out the middle piece, then you can put it in the hole, slide it apart so it's tight, wedge the other piece of wood down in between it so it's tight. You have your holes drilled in it for your coax and close the window on top of it. Works great. Now, that way your coax is going to be running through the hole, so you got to put a fitting on the inside. But if you plan ahead, don't put a coax fitting on until you get your wire run, and you're okay. You don't want to have these fittings outside. Reduce the number of fittings you have outside. Your PLT 59s or whatever you use. That's the way to get them all in the house. I got 9 run in, several of them run in, and it's just kind of a little conglomeration over there at the window. But since I got all that colored tape over there, I know which one's which. So it works out pretty good. But that's one other thing you can do about getting your stuff into the house. Let's see what other little trick we got here. Now, disconnecting. Now, this is just a matter of how you feel about it. Disconnecting your antennas. Now, I believe in unhooking your antennas if there's any chance of any kind of storms or anything. I don't trust switches to disconnect antennas because there's a certain amount of feed that with certain levels of power, can jump over in some of the cheaper switches. What I believe in is unhooking the coax. You got a barrel connector, coax hanging there, other pieces screwed on it, your radio. Go over there and unscrew it. Lay it aside. That's the best way to disconnect your feed lines coming into the house. I do believe in that a lot. Now, next thing I want to talk to you about is supporting the antennas. A lot of this is about portables, y'all probably already figured out. But you can, of course, hang it in the trees. You can put up some kind of a fiberglass pole. Then you got to figure out how you're going to hold the pole up. So you could dig a hole and stick it in a hole, or you could drive a stake in the ground and tie it to it with duct tape or something. You could hook it on a picnic table. That works pretty good sometimes on certain tables. You could use a tripod. Now, I got a little tripod right here I like to use for that sort of thing. Works real well. Got a fitting up here on it so I can screw my stuff onto it. Another thing you can do is put 3 ropes on it and have your tripod pipe pull on the shaft and stick it up. Keep it anchored 3 directions so it won't fall over. You could hook it to a friend and tell him to hold the antenna up there. Or you could hook it to a kite. You could hook it to a balloon. Now, if you got a car with you, you can make you up an L-shaped piece that you drive the tire up on and then have a little piece sticking up to hook your pole to beside your car. But there's one other way you can do this pretty easy. Go down to Home Depot or one of those type stores. Go back to the bathroom section and make a little handle thing about yay long, suction cups on it you put in the shower. Buy you 2 of them. Take those things with you when you go camping. Park your car close by where you're going to be working. Stick both of them on the side of the car on the door, one above the other. Tie your pole to that. Didn't hurt the car. You get ready to go. Take the rope off of it. Take them loose. Put them in the car. Drive off. They work good, I can assure you. Let's see, what we got next here? Now, the next thing I want to talk to you about is the standards. I think you should, as being a ham radio operator, you need to consider today is one thing that's going on, but you hope down the road you're going to be a ham radio operator until you go to the grave in some manner. So you want things that are going to work out later on that you're doing today. So you kind of need to have a few standards. Like one of mine, I like PL259. I don't have anything to do with end connector. Some of you might even know what an end connector is, but it's a high-class way to hook up coax is what it amounts to. So I like to use the PL259. If you're doing anything with audio, most everything you buy today, except for some ham radio equipment, uses 8-inch type plug. I call them 8-inch, 3.5 millimeter or something like that. But anyway, I like to do all my stuff with the smaller type of plug and jack, the 8-inch side, because if you got a 1/4-inch plug on there, it's got some length to it, and then you put an adapter on it to get to the 1/8 inch. It gets long, sticks out in the way. Now you can get L types and change that, but they're just kind of bulky. So if you always put 8-inch plugs on, then all you got to do is put a little adapter on it, which is makes about half as much added on to it with that as it would if you were using it the other way around. So I like to stick with that type situation. 2 things I like to work with is copper pipe. This is copper here. I've got a little paint on that one, but anyway, that's a little piece of copper. And also I like to work with PVC pipe. Now copper pipe will conduct electricity, and PVC pipe won't. PVC makes great insulators, and in fact I have a little 2-meter antenna some of you might be familiar with, and I made it out of 4 pieces of PVC. I got the wire inside of it, and it gets out to the repeater real good. And there's one similar to it in York, and I think it gets out to the repeater real good also. But anyway, PVC is a good one to work with. But if you're going to say, Steve, I don't know about, I think I could handle the PVC, but they glue it together and then you can't take it apart once you glue it together. So don't even think about gluing it together. That's ridiculous. Don't do that. All you got to do is just get out your drill set and drill your tiny little hole where the fitting of the pipe is both under it. Drill you a small hole. Get you some little small self-tapping screws. You buy those in little packs in places. And run that screw down in there. So it'll stick inside. Now if you're going to put coax in that thing, after you get the screw in, let's say your screw is a little bit too long. You don't want it sticking in the pipe there too far. So you just back it out, take a device and put it in or a pair of channel locks or something where you can hold it and get your grinder out and cut it down and shorten the piece of screw up, because you've already made the hole, you've already made the tapping in there for it, put it back in there. So that way everything can be taken apart later on and put it back together. Now a lot of times you put it back together, you won't line it up the same hole, just really another. But PVC is a good thing to work with, real good. Now, if you're using long pieces, it's kind of flexible, and that's still what you got to look at. Copper, you got to solder it. Now you can put the screws into the joints on copper, but I found that you got to probably drill that hole 4 or 5 times in order to get that self-tapping screw to fit in it and be tight. If you go too big with it, then you got to get a bigger screw for it or whatnot. So it doesn't work as good with copper. So you might have to solder it. And you can see like this kind of messy soldering job. My brother's a plumber. He does really pretty work with solder. I just make a mess, but then if it gets too bad, I just paint over it, let it go like that. But you can use solder. If you really need any solder done, I've got a torch and all that stuff, and can do it for you if that's what you're trying to do. Well, let's see. Now, ends of your radials. We're going to talk a little bit about radials. I have been in the past putting RCA plugs, because RCA jacks and plugs have 2 good contacts. There's a pin that sticks into the hole there, and then there's a shield outside that fits around the other piece. So it's a double contact. I haven't been able to find very many lately and order them and whatnot. So I'm in the process of changing over, and that's what's going on this little booger right here. There's going to be some alligator clips. And then on the ends of my radial, where I've got the RCAs, and on this one I even put bananas on it, but I'm going to put me some alligator clips on it also. That way, the 2 alligator clips can hook together, and that's going to make a pretty good mechanical and electrical joint. So I'm trying to standardize all my stuff over the alligator clips and get away from the RCA plugs. Let's see. All right, maybe we're going to have to change pages here. Am I boring you yet?
No.
Okay. All right. When that comes up, you know the hand signal. Another thing on standards that people are doing, most everybody's gone over power poles. Power poles is a really good thing. If you don't use them, you really should think about getting into power poles, because they're the one plug that the 2 pieces are just alike that fit together. You don't have to, it's not like, well, I don't have, like this one is RCA, well, this is one type, yes, I can say female, and then the other type male, and you got to have both of them. So with the alligator clips, you don't have to have both, and with power poles for all your electrical, they all fit together. And they also made on the, if you ever look on the jacket of one of those things, they got little grooves and things in them, ridges in them. You can put them together in a different manner other than just the black and the red together. You can stack them up on top of each other. You can put 4 of them together. I know one guy that does that on some of his stuff. Puts 4 for his radios, I think. But anyway, that's one standard, one of the last standards. I think you need it. But do keep in mind what you do now. What's it going to do for me down the road? That's a good, I think, a good thing to look out for there. All right.
Steve,
Sir.
one thing you taught me was on the back of your radio,
Yeah.
you'll splice in a power pole with the T connector, so you're ready for any kind of battery connection.
That's a good thought. Yeah. That's a real good thought. Because some of the radios do come with those weird looking kind of pink colored plugs on the back of the different things. So that's a good, very good point. I appreciate that. Now, next thing I want to talk to you about is joints, coax joints on antenna systems that are out in the weather. Putting 2 coax PL259s and a barrel connector. Of course, now this is a real long one here, but it's got a little short barrel connector. And you put those together. I think you should try to keep that joint for those two vertical. Wire goes this way, wire goes that way. So vertical, rather than laying them down. Do them vertical. And you need to use your electrical tape, and you need to wrap it with 3 layers. And you need to start on that thing. You want to wrap up the tape first, up the fittings first. Go up it first. Well, when you look at it, that looks like the water could run down on it and get between the tape and go down in it. But then as you get up to the top of it, up to your coax, then turn around and wrap it the other way down. And then you still got that idea of where that's going to get, water to get in there to some degree, some way. But if you go back up that piece of joint there, go back up it, every row you go around it is lapping over the one below it. So now the water's going to come down on the outside of the tape and shed to the next one, the next one, the next one, and run off. And your water's not going to be going in behind the tape and getting in it. So I like to wrap it, like I say, 3 times and make sure the last one is going down, going up on the thing. So you're wrapping over itself, over part of its own self. I want to talk to you a little bit about building coils and things. I like to build mine with PVC pipe. Inside this coil is PVC pipe from one end to the other. We bought the already made coil, but it's not mounted anything, it's just a coil. It was really about that long before I put it up. But anyway, in here I've got a piece of PVC pipe, a coupling on this end, a coupling on this end, and they put together with those little screws. All right. Now, what I get a hold of, and on this coupling, I buy a plug. This piece here's got a plug in it. This got a little bit of glue on it. But anyway, you buy a PVC plug, and you drill a hole in the center of it. Now, there's a trick there drilling that hole in the center. If you get back to shims, you got your bit, 3/8 inch bit. If you wrap some tape around that bit about 3/8 of an inch above where the tip of the bit is, you can use that plug and stick the bit down in it, and the tape will keep it in the center of the plug, so you can drill the hole in the plug. Now the plug, you can stick that's nothing, I better tell it too. It's all these type of antennas and things use, I won't use the word weird, but they use a different thread than the normal national thread. It's 3/8 inch by 24 threads to the inch. Regular thread bolts are 16 threads to the inch. Even though they're 3/8 of an inch in diameter, the thread is there's less threads on them, and it's smaller thread. So watch out about that. Be sure you get into the 3/8 inch 24 thread to deal with this type of stuff. These little couplings, you need to buy those the same way. You get one with of it where you screw it right into it. Now that's another little thing I've screwed into there. You hook a wire to it. I don't agree with that, but that's what shit. Screw that into there. So now you got a male thread on the bottom you can screw in. You do the same thing on the top up here. Same thing with that little plug and the bolt and the nut, and then you put your a coupling onto that bolt, and now you got something that you can screw your antennas into. Now you have a coil you can mount somewhere in 3/8 inch, and then you got a place to put a whip in 3/8 inch. Then you got your good portable system there with that. That's the easiest way to build those things. They're a little bit aggravating working with all that stuff inside as you're putting it together. But if you do it a few times, you can get used to it. And if you get in bad trouble, just call me. I'll come help you do it. Okay. I want to tell you a little bit about coils. This one right here is a tapped coil that you can't change the caps on. There's PVC right here, PVC here, and all through here is PVC. And this is that same little plug and same little bolt up here at the top of it there. And then, it's actually going to be on the bottom of this one. And then up here I used some copper to get on up to this. And I used a cap on copper and put the bolt in it. That's what's holding this little piece here. So now I put my antenna on top of it. Well, the way I made this thing up, I made the bottom, but I didn't make the top up. This had the PVC pipe there. I got the wire out I wanted to use on it, and I figured about 19 inches would go around it about 5 times. So I cut all these pieces of wire 19 inches long, and I skinned out about 1 inch on each end of them. And I started off with the first one, and I hooked it down here, and landed up here and went around there a few times. And I rigged up a little device to just hold it on. My wife didn't want to come out here and hold the wire for me, so I hooked the next one. So I made a little device clamp on it. But anyway, you take the next piece of wire, and where that one comes up, twist them together. And then you go around another 5 times, and you got to twist on another piece of wire. So every one of these things is a different piece of wire. Same kind of wire, but it's a different piece of it. And where it's joined together, I slipped these little eyes on there, and I soldered them onto the wire. So now the wire is joined together, and it's got that on it where I can tap it real easy. I can even make a permanent tap on it with a screw there. And that's how I got a coil here I can use, and I can tap it at different places, but I can't tap it anywhere like this one. So you got a good variation with this one. With this one, you got to depend on your tuner to get you from the third white over to the third green or something. So it's not as good there, but the tuner will take care of that. Tuner will take care of a lot of stuff now, a whole lot of stuff. But anyway, that's the way this thing was made right here. I do like making coils and things, as you've probably already figured out. Let's see what else I got on here for you tonight. I don't know how much time's running right now. Okay. All right. Next thing, if you get white coax together, and you say, well, you don't do that. Well, yeah, you don't, but you can if you have to. So if you got to splice a piece of coax together, the thing you really need to do, and if you do have access to being able to use shrink wrap or shrink tubing, you can use it with it. Or you can use that old deal with the black electrical tape. You can wind that with it in the end if you have to. But anyway, if you clean your thing up, cut you off about 4 inches of the piece of coax you're working on. Skin the jacket off of it, and then kind of bunch up the shield that's inside, the web that's there. Bunch it up. And slide it up on one piece of the coax you're going to splice. Get it out of the way. You may even have that piece of shrink over there with it. Then you want to clean that up. You want to skin it out where you get down the center conductor, where you can solder the center conductor of the wires together. And you want to tape that up pretty good. Then all that fuzzy mess of shield that's in there that you just kind of pushed out of the way while you're working, kind of work it back together a little bit if you can. Get it back together. It'll look like a mess, but you can do it pretty good. Then slide that other bunch of shields you got over it and stretch it back out till it kind of pulls against all those other little fibers of shield. And then go around and do some sorting on it. So you're sorting the new piece of shield to the old piece of shield. And then you get all that done, and then you can get that black tape out, cut it on a 45 and start wrapping it around there and get it real tight around it and leave the last 4 inches slack on it. And that way you can splice coax. Now people will tell you, no, don't do that. Put two PL259s on it, and then put a barrel connector between them, and then wrap all that up in tape. Which is probably the best way, because then you can go back to it and take it apart. But if you're in a bad situation, that's one way you can splice a piece of coax. Next thing I got for you is trimming wire antennas. This is about down to the end here. Trimming antennas, wire antenna. There's a formula. Some of you may already know this formula or you've done this before. But what it amounts to is, let's just say that you're going to pull your wire out there, and according to your calculations, you're using the formula of the 468 factor, which I think probably all of you know the factor. It's 468. You're going to use that factor, and say you want to shoot for a frequency of 7.2 or 200 on the 40 meter band. So you do some calculating, and you come up with 65 feet. Sounds good. We'll run some wire out there 65 feet and put it up and see what it does. So we do. We put it on that insulator and that tree, and you let it hold the other end up or whatever, and you check it with your meter. Well, your meter shows up that it's not on 7200, it's on 7100 or something, some number. It's not where you want it, and you want to change the length of it to make it do what you want it to do. So the next process you're going to have to go through is you take that number that you've gotten, frequency that you found. Instead of 7200, you found 7100. And once you get that 7100, you want to use it to come up with a new factor. So if you multiply that rascal, I think you let me say it right. You multiply that frequency out, you're going to come up with a new factor that's a little bit different from the 468. Now if you use that factor to figure the length of your antenna, then you'll come up with, in this case here, with what numbers I use, I came up with 461 instead of 468. When I worked that all out with 7200, now my antenna needs to be 64 feet instead of 65 feet. But then it'll be on the frequency I want it on. So that's a formula that you can use for that. I don't know if y'all heard of that one or not, but that's one way to do that. And it's just about to end, so if y'all hang on a minute. The other thing I want you to do is think about an antenna. When you're working on antennas, don't think of it's an antenna. It's a system. It's a whole system. It's not just the antenna. It's the whole works. And you start off with it, well, you got to start at the back of the radio, and you got to get that antenna system over to the tuner if you're going to use one, or over to whatever you're going to put in that line, like a lightning arrestor or whatnot. But you got to run that over. Well, that is all part of that system you're working on, not just the antenna. And once you get the coax or whatever kind of feed line you're using running through there, get it over the antenna and hook it up, put a ground system on it, whatever you need. But don't think of it as, I'm going to put up an antenna and start thinking about putting wire up in the tree or ground plane up or something. Think of it, hey, I got to figure out this whole system. I got to get out behind that radio. I got to get through the floor or the wall. I got to get out there to where I'm going to mount this antenna. I got to get up in the tree with it. Then I got to some way or another support the thing. That's another whole system in itself, supporting the antenna. You get it supported. Also, you got that other little system of grounding it, if you're going to put a ground on it somewhere, or your radio system is another part of the whole thing. So all that, just think of it as an antenna. It's not an antenna. It's a whole system of something to radiate the power out of the back of that radio so it can jump off the end of that element and go somewhere. And that's what I have so far. If you have any questions, I'll be glad to try to answer them for you.
Steve, one of the things you talked about when using those Acorn
Yeah.
connectors is to go out 3 or 4 days later, tighten that again.
That's a good point.
Yeah.
Very good point. He is definitely right about that, Charlie. Definitely. That copper will kind of
loosen up a little bit.
yeah, they will. In fact, every once in a while you kind of need to check all your connectors. Anybody else got any kind of questions? Well, either you understood everything or didn't need it in the first place.
You did a good job explaining. Very interesting. And now you know why I call him a living legend. The guy's probably forgotten more about ham radio than most of us know in this room. So thank you very much.
Oh yeah,
Steve.
I did miss 2 pages, excuse me.
Wonderful. Thank you again.
Thank you for letting me
Folks, I want to share some good news with you. Next month, we will not be here at the clubhouse for presentation meeting because we have a special guest. He's coming to us from Talmadge, Ohio via Zoom. It's K3LR, Tim Duffy, CEO of DX Engineering. So we were able to secure some time with Tim. He's going to come in via Zoom. We will live stream this on YouTube, but the club members will be on Zoom. And we have an account set up that we can give enough time for Tim to do it with enough people. And we'll have it live. For those of you who are not club members, we'll have it for there. So Tim's graciously agreed to do a presentation for us. And so we're very excited to have Tim Duffy, K3LR. And for those of you who don't know, besides being the CEO of DX Engineering, he is probably one of the most accomplished contesters in the world. He has participated in the World Radio Sport Team Championships on several occasions. He has won numerous awards. He has a super station not too far from where I grew up. I think there's 16 towers on the property. It is an impressive site. If you Google his address or QRZ his address and then Google map it and take a look at the overhead of his property, and if you're ever fortunate to go up to DX Engineering and catch on the right day when they're doing them, they actually do tours of K3LR stations. So it's a thing for us to catch him to do it for us. So look forward to next month. And with that, we've got open house first month with. No, not HOA. He's got quite a bit of property out there.